Hello and how's it going, everybody? Here this is another video on the intermediate React version 5. This is a course taught by Brian Holt, a software engineer that has previously worked at Reddit, Microsoft, Netflix, also Snowflake, which is a data lake as service, and now he's currently the VP of SQLite, right? So this series of videos is just a couple notes based on this course, a course that I can show you to you since I already received some flags from from the master as a way to say, hey, you can learn from our courses, but you can't record yourself while learning. So because of that, this video is focuses on me taking notes, and in this particular video is more about recap about this advanced React performance. So this advanced techniques in like code splitting, server-side rendering, node stream, and server-side fetching. Okay. So the goal of this course is for developers like me be able to write production grade React applications. Okay, so once I already look at the core of React, which is how do you use React from the browser, and then the core features, like first things first, you need to know what is the linter tools that we're gonna use. ESLint, TypeScript, unit testing. This will guarantee is the correctness of your application, as well as prettier. Also, you need to learn part of the core features of React is GSX, hooks, use effects, custom hooks, forms, controlled and uncontrolled forms. How do you handle events? Then look at how you can create and render lists, component composition, what is the logic behind that, while developing or while looking at what is the React DevTools and some sidekicks or use cases for React DevTools. And then this is part of the core of React. And then, well, take a look now at the React capabilities, which is React router, React router, React query, something that he didn't mention, but I will bring that out, which is React hook forms. Know the subtle difference between uncontrolled forms and controlled forms, as well as class, the difference between class and functions, how you can handle is events in class, what are the subtle difference between the class and functional components, looking at the special cases of React, which is another model. Here we got is the error boundaries, the models or portals, as well as context. Where you're going to store is the state of your application. So this is just to summarize the React core concept, the introductions. And here, so once you know all of this, it is time to move on to the next topic, which is how you can help companies or clients to build out this production ready applications, especially to make your life much more simple. Okay, and here we're going to look is tools and techniques to do that. Techniques like code splitting, server-side rendering, testing, and transitions, as well as tools like TypeScript, uh, sorry, TypeScript, Tailwinds, and Redux. Sorry. uh, yeah, I got a couple. I got a little bit of flu. So move on. So here again, the top priority of this video is to take a look at the advanced React performance. We're gonna walk through quickly to the hooks and depths and tailwinds to make a TLDR. So hooks and depth is just to cover specific use cases that you might find need when you're developing React or React Native apps. Okay, so for example, use ref when you want to get the reference of an HTML document, or when you want to get a reference of a particularly operations or computation that you can later on do that. So the other is the use reducer, which is something that is quite familiar or quite common if you are familiar or you have surface level with the Redux, where use reducers is just a fancy name to say this is a function that takes an state and an actions that will generate a new bit of state. That's all. Okay, and the way to do that is by using is object.create, which is generate is a new state for that. It doesn't mutate the object, and this is also come from the concept from immutability, part of the functional programming. So the idea here is that make your life much more easy, especially when you have to debug your app and maintain while scale that by adding new features. So this is use reducer. Then we have is the use callback and memo as a way to avoid re-rendering the elements. For example, for expensive computations or expensive or re-rendering components. So you can pretty much think like if you come from the view world, that this is like computed property. So based on a particular property, okay, so when that changed, I'm going to rerun this computation as long as this computation has run previously. So this is like a catching. Again, premature optimizations can be the root of all evil, but again, if you find yourself maybe need to or avoid expensive recomputations or avoid re-rendering components, use callback and use memo might be the way to go. Okay, then I look at the use layout and use ID. So use layout, it say, hey, because use effect is rendering right after the render function. When the render function ends, when you need to, for example, touch the layout, let's say a use case is you want to resize an element on the UI. So instead of actually every time you detect a change event, you will going to call that function once that layout changed. So for example, once you change the text area here. Again, remember that all of these are very special use cases for Facebook. So Facebook has their own problems. Your company might not have those problems. Okay? And the other is the use ID, which is one of the main use cases for giving IDs to the forms. Okay, do not use this as rendering and give key to your list. They are not meant for that, and in fact, those unique identifier or key must come from the database, at least in an ideal world. And that's it for this hook in depth. Okay, and then once you know this sort of tools, next is tailwinds. The TLDR of tailwinds is that it allows you to write CSS code. It will tell you how your application will look like. If you want that, you might want to use these system designs like Bootstrap or Material Design, where every time you use or every time you build a website using those, your website will look like them. Bootstrap or Material Design. The thing here is that for internal use app, that makes a lot of sense. When you want things to feel good enough or nice enough to your users. But when you need to find is, or when you find yourself in the marketing sphere or in a creative agency, you might want to have some sort of flexibility here. So TypeScript, after all, and Tailwinds, after all, what they do is that you say, hey, I'm just going to allow you to use all of this little tiny CSS that later on it will be passed through the Tailwind compiler, and then generate is the minimal set of CSS. From their docs, they say that maintaining HTML in CSS is way much more efficient than having a large CSS code base. So I look at how can we install that, what is the main component, what is the anatomy, okay, the compiler, the Tailwind compiler, the Babel, or in this case the the Babel that they use, or some sort of Babel like Post CSS, which allows you to use is the new CSS syntax on all the browser and make it compatible across the entire browser landscape. And the auto prefixer. How can we start to use that? How can we extend the functionality of our Tailwind? How can we create layouts in Tailwind, which is something very, very powerful? And then, how can we is now adding plugins to our application? So that's quite interesting, because now that I know, again, this another badge, this another badge, or this another tool in the toolbox, okay, then we look at the techniques that allow us to write this production ready application that will help clients to solve their problems, and pretty much say, hey, we're making your website much more faster by using these particular techniques, so you can improve the user retention and user conversion as well. Okay, so code splitting. The TLDR of code splitting is that you want, or the value proposition of this is that you want to send the minimum necessary code to teach your app to get up and running, so users can see something immediately, okay, and then hurry up and then hurry the background with everything else. So that's the entire, what is the value proposition of this? Why is this? because let's say you want to set your uh, limit or your initial load to 100 kilobytes, right? So React DOM by itself is about 42 kilobytes, and the React version 18, which is the developer surface, is roughly 2.5 kilobytes here. And this is all about 40 or less than 45 kilobytes minify. So you have now the rest, 55% to actually bundle all of your codes to fulfill this limit. Again, this is not a strict limit, and for that I'm not encouraging you to put that here, but you must have at least some sort of initial low budget. Why? Because, for example, uh, you need to have this or something that you want to stay under, or a performance timing that you're trying to hit. The reason is that, uh, for example, if you're building apps like Ubercopter or Uber Helicopter, where they probably have a good or they probably have a decent connection, and you can probably have a pretty performant budget. Okay, if you're writing an app that keeps tracks of farmers that's watering their crops, or any field service uh, applications, so for example, a dispatcher is sending an expert to the field somewhere out there in the boonies, perhaps in the South Dakota and Oklahoma, okay, to provide some technical assistance and inspection. Uh, for example, in the case of wells, in the case of energy and industry, the energy and oil industry, okay, you want to send some truckers, you want to send some drivers to actually do the hauling service. So here, when the connection is when they might have some areas of terrible connections, uh, you want to have a or your budget is very sensitive. So things like this, especially on loading the initial bundle for your applications, okay, it becomes essential here to split these things or to split the main package out of it. Okay, so in the real life, you're going to work most of the time for to solving problems with people with money. But if you find yourself with uh, good enough capital, you might now have the time and energy and resource to solve those uh, poor cold coverage areas. Okay, now how now that we know what is the value proposition of code splitting, next is what is the detail about it. Okay, so how can we implement that? So React helpful. So React expose a function that allows to do this. So by adding the lazy from React to a particular React component behind the scenes, React will gonna say, hey, let me now split this particular component into several chunks that are followed by a hash. Okay, so as you can see here, by using the lazy as a dynamic import, okay, and then anytime you want this to render when something is loading in the background, uh, you you need to use suspense. This is to show, hey, I'm gonna show the fallback to the user uh, while something here is or while we're rendering the render 3. until suspense has returned. Okay, so you may wonder, okay, that's something interesting, beautiful. Now that I know how React actually split the code here, uh, or do the code splitting, okay, there's another question, like how React knows when to load those resources, okay, and how React knows, uh, because it's this, so how React knows when to load those resources, and how React knows, uh, how React knows when to load those resources. It is safe to assume that we can rely on there. Okay. So this particular image here is just a way to show what it's doing behind the scenes. So this is the chunk business here from React, which is something that I mentioned. Hey, React, what it does is to generate is this hash for that. Okay, for us when they say, hey, this chunk of data, now it weighs this. Okay, and the thing here is that, okay, because we're using this feed behind the scenes, it's actually kind of hard to do that because they using is the browser built-in model loaders, okay, for serving things locally. So the cool thing of this splitting or code splitting, for example, in the detail page, is that it is only be loaded when it is required. So we split the particular code. So you must be careful of when and how massive you want to do this code splitting, because the objective is to make your application faster, no slower. So target bigger low or target bigger chunks will help you to do that. So splitting 8 kilobytes is not worth it, but splitting 30, 50, and 100 is where you want to start. Again, this is not a silver bullet, and please measure your app, and please measure that that you are making the user experience better, not worse. Something important. Why is that? Because anytime that you're working with this code splitting, it's pretty much like the shell game. So if you move something to make your initial page, if you move something to make your initial page fast, or your initial pane faster, I'm making my time deck. I'm taking my time deck interactivity worse. Okay. So if you have a big app, you need to do code splitting to get a decent performance. Again, this is if you have a big app where you can start by splitting things, but you can start by splitting things for 30, 50, and 100 kilobytes. This is when you want to start. Again, remember that the whole point of this is to make your app faster, not slower, improve the user experience. And when you're playing with this, okay, it's pretty much like the shell game. So while you're making your initial pain faster, I'm making the time that interactivity worse. The key here is balance. But a question arises for where the code rested when we put lacing, okay, and how React knows when to call this uh, code. So two questions here, because it's like how React knows how to call that render or that chunks of data. That's one, and the other is that where that chunk of data live. So this will open up a box called the service worker. Okay, which this is the best way of how you can is let your app to say, this is a chunk of data that we want to load, this is the chunk of data that we want to catch once you load it. And with service workers, if you're not familiar with the concept of that, this is just sit between the application and your API request. So it will check that if you have this research, for example, the user wants to load the initial page on an e-commerce. So if you already have that, the service workers say, hey, before sending this request away, let me see if I have all of these bundles assets locally. If I not, then let's go. Let's make the request. Okay, and now with the response, and then I'm going to store all of this resource that I have on this manifest that is generated by the model bundlers, where whether it's Vid, Parcel, or Webpack, where they tell you, hey, this is the list of resource and assets that I want you to store locally, okay, and cache that. And you can also define some additional configuration for that. The thing with this service worker is that it allows you to offer offline capabilities, push notifications, as well as it will going to change your architecture as well, because now you are integrating is a new mechanism here, a new mechanism of how you can make the user experience as fast as possible to improve the user retention and conversion, so you ultimately can increase sales. That makes a lot of sense. Completely, completely, completely. So there is a very interesting, and I think this is something that I will dedicate also quite amount of time as a service worker, because this is something that you can provide value to clients, okay? And you don't have to reinvent the wheel, especially if you're using frameworks like Nuxt. We're gonna see how we can implement that without having to rely on any framework specific. But this is something that go beyond the scope of the work, because it would lead that to like half an hour to describe this. So that's not the intent of this. You have frameworks like Remix, which the people that work on React Router actually now is building this up and coming hot new framework that is competing with Gatsby and Next.js. So yeah, this is something to consider, okay? Something to consider, this PW service worker. All right. The other is now server-side rendering. So far we have looked this particular technique, which is code splitting, a very interesting way of how you can make the initial page time load faster, okay? And how all of this in the inner mechanism and the anatomy and the inner mechanism, what it's doing. And then the another technique, which is server-side rendering, as well as no string with express and server-side fetching. The entire reason of server-side rendering, which is something that we did before that, okay, is that we're going to reduce the initial render page and increase the interactivity time. So this is the value proposition of the server-side rendering. So by reducing the initial render page and increasing the time of interactivity, we're gonna load things in the background So letting the user, so while the user is trying to understand the website, we're loading everything that is needed in the background, so then he can interact with the application. And this server-side rendering, um, there were two particular ways of you can do that in the past. So you say, hey, let's go to render this entire HTML and then send to the client. But now we can say, hey, let's go to render chunk of the HTML and sends to the client as is available. So the idea here is to avoid the frustration when navigating your app and bouncing, okay, with the server-side rendering. So here we're going to create a client JSX file where we don't have to define anything that is being used in the browser. So we define here is the server-side rendering. What is the value proposition of server-side rendering? And the idea here is that we're going to now reduce the initial size of the render, or we're gonna reduce the size of the initial render page. And there's a subtle difference between the initial load page and the initial render page. Okay. One of them is how long it will take to download all of these assets, and the other is that how long it's going to take for the browser to render something. Okay, so we're gonna reduce the size of initial render page and increase the time of interactivity while we are loading everything in the background. So once the user sees something, he can, while they're trying to understand what's going on, we are loading all of this, and now he can interact with that. The whole point of this is to avoid user frustration when navigating our app and bounce it. So how React actually do this? That's a great question. Okay, and how React actually solve this, help us here. So in React, we need to create two files that will contain code relevant to the client to be rendered and for the server. You may wonder, why is this? Because there are code that will be loaded on the client and there are code that will be loaded on the server. Traditionally, the way how we did this is by doing this round trip. Okay, so by doing this round trip, we actually, anytime we navigate to a site, we'll make, so we take some time to load the page. Okay, so the value proposition of the server-side rendering is to decrease that time from the server. So we got here two files. So you got the client and you got the server, where in the client you're going to, as I mentioned before, render things, or hydrate as they like to call it. Okay, so on the client you're going to hydrate things, or in this case React components. Okay, and this is what you're going to load is your browser router. Okay, and here what we did is just to make our applications generally purpose, okay, that can be used on the client side. Okay, we modify here a little bit of the code of the app to make that is reusable, and then we run now. Then we create is a server file, the code that will be relevant to sense that once the user, or once yet the code necessary to render when the user is requests for a page right? So the client side here is when the user is actually in the app, and then he's navigating through the app to consume research from the server. The server is when the users navigate or do a hard link or hard refresh or navigate directly through the URL browser bar to that by sending is a new request to the server. So the subtle difference between that is client app is going to hydrate components or data as the user is navigating once it is in the app. Whereas on the server is that this is the resource that is going to load once the user do a hard refresh or do a hard or call the request from the URL. Okay. Again, React Router, a word on React Router. React Router make this thing easy. For example, to make navigations, to make navigations and routing very very accessible, which is not easy to do that. So we got is here the server apps, okay, and then we got is the render to pipeable string, which is a function that comes from the React DOM server, and as you can see here is this is the client app, okay, hydrate root and browser router. What are you gonna load when the user is navigating within the app, and what you're gonna load when the user do a hard refresh or navigate through your app or navigate to your app using the URL here. Okay, so okay, you got is the render pipeable string for the server and the static router as well as the app. So the render to pipeable stream here is a function that use Nuxt to render small chunks of outputs to be served as they are available, and here is where the magic comes from. Similar to the hydrate root, okay, when they're going to hydrate is component as they're going to be rendered or as they're asked for, hydrate, okay. So render to pipeable stream is use node strings behind the scenes to render these small chunks of outputs to be served as they are available. And this is something interesting because if this component is available, for example, in the case of our app, hey, our app is available, not quite. Okay, what is the render tree that we need to do that? Perhaps the header, perhaps the main. Okay, if the main is the header is ready, yes, send that. All right, and so on and so forth. So this render to pipeable string, that's what it's doing. It uses the node string to render small chunks of outputs to be served. The small chunk of output to be served as they are available. To be served as they are available. Okay. The way this worked before is that you have to render it exactly. So now here we are explaining is how on the server side this actually works. Okay. So the way how this worked before is that the way that this worked before is that you have to render it completely. So for example, if a user wants to navigate to a profile file or a product detail, okay, the thing that we or the way this worked before is by rendering, okay, is by rendering completely before it sends. Of course, it's caused that the main thread to block due to some massive incoming requests to be processed, especially in big application. Now with React 17 and Suspense, we can send them piece by piece. So React here is actually saying, okay, because now I have aware of the context of where I'm going to serve these files. As a way to improve is the initial render time. So while you are showing something to the users, you are hurry up everything in the background here. So whether the scenario is the client or the server, on the client, this is what we're gonna do. We're going to hydrate is all of this data, okay? And on the server, we're going to render, or we're going to render as a stream, render to pipeable stream. That's what we use here. We're gonna send small chunks of renders, or we're gonna render small chunks of output, and to be served as they are available. Okay. So this is now making Suspense. So with React 17 and Suspense, we can send them piece by piece. Makes a lot of sense. So here's now Vite is going to read our GSX file and properly import the component needed. This is in the case of our dev server. So now our dev server is saying, okay, so now that I know what is the file that I need to read, then I'm going to import the proper components from that. In this case, as a GSX server. Okay, because after all, this file will be read by the server. So luckily for us, this is something that Vite is doing behind the scenes. So this is just explaining briefly how the server-side rendering. So what is the server-side rendering? What is the value proposition of the server-side rendering? Unlike the code splitting, where the whole point of this is to reduce the initial page load time, and the server-side rendering wants to reduce the initial render time. Okay, so there's two measures here. Initial page load time and rendering. So on the server side, by doing this, and in the background, we're gonna load all the things that we need to do. So because now we are building applications that work, or we are building is JavaScript applications that work on the server and on the client. So the architecture here is like this. When the users find themselves in the client, you're gonna send them. So when the users are in the client applications already and navigate into that, you're going to hydrate like a plant. You're going to hydrate is their you're going to hydrate is their application as they navigate through. Okay, so it's like essentially loading things as they come out. Okay, a good analogy here of the server-side render or the client-side rendering, or like this, is that you're going to render things as they come out. Okay, or you're gonna ask for chunks. You're gonna hydrate them as things come out. Okay, pretty much in a game, or in this all games when you don't have a lot of computational power there, and you say, hey, okay, we're going to load is just the bare minimum, and so for example in Doom, and as the user move, we're going to later on going to load all of these resources. So okay, and on the server side, if the users navigate direct to our server by doing a hard refresh, or by navigating through your URL, okay, Now we're going to use node streams to render small chunks of output to be served as they are available, like this, like a stream. And that makes a lot of sense. What we're using is an static router from the React router down. It's interesting. React router down server. So okay. So here we're gonna look at what streams is all about. So the idea here is that by letting the React know how to render your app, which is very, very, very important, because after all, it's React that is actually aware of the context of where you are rendering your app. The idea here is that by letting the React know how to render your app for the client and for the server using Vite or any other model bundler, with Express, we're now going to serve such content to the client as soon as it is available. And this is something that frameworks like Nuxt or Nuxt is doing behind the scenes. So now that React know how to render our app, okay, which is, hey, are we gonna do that on the client or on the server? Okay, now that I know in which scenario is the users find itself to render that, now I'm going to use a server to run that, okay, or to serve such content to the client as soon as available. So you can use Express, and in our case we're using is Express as a way to say, all right, let me actually know and show you how you're going to do that. Okay, this is what the 99% of these web apps are doing behind the scenes. They're taking content, or they're interpolating, which is a fancy name to say, hey, I'm gonna take all of this stream, or I'm gonna take all of this stream. Yeah, I'm gonna take this data, and I'm going to generate an HTML with this dynamic content. It can be for any data source, database, and any other data store. I'm going to hydrate it. I'm going to put everything where it needs to be. I'm going to form this HTML. Okay. Once that I did that, then I'm going to use some inner mechanism like string as a way to send that as they are available, right? So a good analogy here is that on McDonald's or Chipotle, Starbucks, is that they're going to serve you your coffee as they are available, right? They're not gonna serve you is something half there. Mhm, mhm, mhm. So the idea here is to, by using node stream, is to render these small chunks of data and send them as they are available. Okay. Oh, a good example here is the inflation here, because the inflation is something that is high. A good analogy here is that you will go to something that you can do, for example, here. Yeah, something you can do examples, real life examples of node stream in our daily life as humans. Okay. provide a real life, provide 5 real life examples as our daily life as human, please. Water faucet. Oh, exactly. Water faucet. Music playlist. Assembly line in a factory. Internet video streaming. I think this analogy is way much more applicable. Water faucet. Think of water faucet as a stream. When you turn it on slightly, a small stream of the water flow out. Turning up more and the stream gets stronger. Just like how you can control the flow of water from a faucet. So this is a good analogy here. Traffic on a road. Picture a busy road with cars floating steadily. Each car represents a piece of data flowing through the stream of traffic. Just as traffic can experience congestions or flow smoothly, stream can encounter back pressure or flow freely depending on how fast that is being processed. But the water faucet here is a good example of this. Especially on those streams. I'm going to generate, okay, so based on this data, I'm going to generate is the HTML, and I'm going to serve you like a water faucet. Anytime that you need that, you're going to get that HTML. You're going to get that water to wash your hands. So that's a good analogy here. Water faucet. That's a good analogy. Water faucet. Yeah, water faucet. Water faucet. Completely, bro. It's like, holy moly. Water faucet. Yeah. This in Spanish is grifería. Grifo, bro. Water faucet. Exactly. Water faucet. Alright, okay. So yeah, I like that analogy here. Or the water faucet, because this is something that will continue use that. Water faucet. So this node string, what it's doing is that. Okay? So it's say, so now that React actually know how to render your app in the client on the server. So now that React is aware of when you're going to render your application, whether it's on the client and on the server, and depend how the user, and we got these two scenarios because depend where the user is navigating through our app, okay? Whether it's if they're navigating through the app once they are there, okay? Or if they're navigating our app once they hit, when they do a hard refresh, or they navigate using the URL, okay? So on those scenarios, now that we make React aware of that, we need to find a way to serve such content as soon as possible to the client. And this is what frameworks like Nuxt and Nuxt are doing behind the scenes. So the whole point of this is to look at what they're doing here, because we're using is no versions 18 as a way to say, hey, this is what we're going to look. Again, there is a lot of machinery here in the background here to actually be able to write this thing. So let's do it. Let's do it.
All right, let's go write our node server. This is going to be outside of source. So here in the root directory, write a server.js. We're going to be doing this in ES6 modules, which can be kind of a pain with Node, but it's fine. Import Express from Express. Import FS from FS. Import path from path.
Yeah, we're
bear with me, there's a decent amount of typing here.
With
import file URL to path from URL.
Exactly.
And import render app from source slash, oh sorry, we actually need /dist /server app.js.
E6
Now,
model.
this doesn't exist yet, right? We need to build it, which is before we run the server, we have to run npm run build :server, and then we can run npm run start. But we can't import the JSX file directly.
Exactly. Because it's this. Okay. So the render app is a function, or the render app is a function that is a function that we can have access. The render app is a function that we can have access once the render app function here. This is on the server.js. So the render app is a function that we can have access once once we generate is the server code.
Before we run the server, we have to run npm run build :server, and then
so the render app is a function that we can have access once we generate once we build the server file. Okay, once we build the server file, something that he didn't mention here, or I didn't put it here, but that's fine, because now we can take a look at the here. All right, and say things like this. Okay, so for import, so you got it on the package JSON where we add this, like so. So this is script added to our package. Yeah, these are a script added to our package. These are a script added to a packet.json, like so. Where this will going to generate is those built for us. Something we are going to use when we send to, so when we send with Express.
then we can run npm run start. But we can't import the JSX file directly. It has to be built.
Exactly.
Okay, const dir name, because we are in ESM modules with Node, dir name doesn't exist, which is a constant annoyance to me. So we're going to say path.dir name file to URL path.
Yeah, this is to
Import
indicate is the
meta.url.
current file name here.
This
We
is a
say
very weird
path
thing, but
dot
basically, if
dir
you're used
name.
to writing
Path
Node,
is
this
something
is how
that
you
comes
generate
from
what was dot or underscore dir name before.
so dir name here is something that you can see right now what I'm doing, and what I'm doing is just basically is writing this thing over. Dir name here. In fact, let me actually show you what I'm doing here. Application here. The application activity monitor code. Exactly. All right, there you got it. Now you see. Well, actually, you can see that. There you got it. Okay, now you can see that much better. And then you got it. Okay, let me do this. Okay, so you can actually see that. All right. I think you can do this much better. So comes there. This is the way of how you can make sure that you are in. So you have a variable. This is an annoying variable that you make sure that you are in the current folder file structure, the current file. So we're gonna make use of path, which is part of this feature that come from Node. We're gonna use it their name, okay, and here we're gonna set is the path. Here we're gonna make use is this feature come from URL internal node model, which is file to URL, which is a function that say, hey, this will return a string, the file URL string or URL object to convert to a path, okay, which is actually is it is cross-platform. That's the whole point of this. It works on Windows and Unix, and that's one of the reasons why we're doing is this. And then we say there is a global object called import in no environment that can give us the file name. That can give us or I mean is this is a URL. The absolute file URL to the model that can give us is what is the absolute URL of this model. Why is this important? Especially because if you're working locally or on another server, it will now give you the proper URL on the server. So okay, this is something fun. The next thing here,
If this is unfamiliar with you, just know that this dir name is now whatever directory we're in, right? So it's going to be, whatever directory in our project that we're in. Const port, this is the port we're going to listen in.
Okay,
Either process.env.port. This is just a convention for cloud computing. So if something passes in a port, we'll use that for our port. Otherwise, we'll use port 3001.
Exactly. We can set that, but this is more like a convenience, like a convention using from anytime you define any React application, process.env, process.env, use whatever is on the process.env port. Otherwise, set that to 3001, I think we use it.
This default const HTML equals
okay. Here
fs.readFileSync path.resolve dir name and /dist/client/index.html .toString.
Okay.
So what this is going to do.
So here we're going to define now is the HTML. It's like, hey, let's going to actually grab the index.html. Okay. And we're gonna read that file here, which is file exactly file read file sync, and we're using is file sync. You have to be careful with that. So if your file is small, you can do this, which in our case, if you look at our project here, our index file is actually something that is I don't revealing finder here. Open with, rename, compress. Quick look. No, but come on. How can I look? How can get info? This file is actually weighs 4 kilobytes, which is awesome, which is great. Actually, 4 kilobytes, no problem.
Do is our project is going to build out an HTML file. We're going to
Okay.
go read that HTML file because we need all the paths in there, right? We need where the CSS is, where the JavaScript is, because they have like all these hashes attached to them, and so we don't know what they are in advance. So we have to do this part to go get the proper paths for all those different things. In other words, we can't just use the source file because it's not going to be client app.jsx at the end. It's going to be some hash named JavaScript.
Exactly.
In other words, we can't just use the source file because it's not going to be client app.jsx at the end. It's going to be some hash named JavaScript. Script is because they have like all these hacks. Just going to build out an HTML file. We're .toString. So what this is going to do is our project is going to build out an HTML file.
So here is this. So our project is going to build our HTML file.
We're going to go read that HTML file because we need all the paths in there, right?
Okay. So our project is going to build our HTML file, and we need to read that file, which contains all the resources.
Where the CSS is.
So our project is going to build our HTML file, and we need to read that file since it will contain since it will contains all of our CSS, JavaScript,
where the JavaScript is because they have like all these hashes attached to them, and so we don't know what they are.
Exactly. Because they have all of these hashes attached to it
in advance. So we have to do this part to go get the proper paths for all those different things. In other words, we can't just use the source file.
To resolve path resolve. Okay.
because it's not going to be client app.jsx at the end. It's going to be some hash named JavaScript.
Okay. And we're using, okay, to attach it, so we have to resolve all of our path, all of our path resources. And that's the reason why we're using is path.resolve here. Path.resolve of the dir name example path.resolve of the dir name path.resolve of the dir name, and here is when we say, hey, this will live now under the this folder, this client index.html. And once you do that, I want you to transform that into string. Yeah, I want you to transform that into a string. But again, because after all we have to build all of our, exactly, we have to tell our React app, hey, we're going to build is, and then we're doing is for the client side. Okay, and we're doing this is for the client side.
Okay. I'm going to split it into two parts because.
So we're gonna split it into two parts. So because we're doing is the client side rendering, or the server side rendering for the client. This first part is sent back to the user immediately, while the remaining part is returned once the reapplication is hydrated. Yeah, the HTML document is split in two parts here. So exactly, the HTML document is split into two parts here.
When a user makes a request, I'm going to give them the head first. So looking at my index.html again. When a user loads my page, immediately we can flush out to them all of this, right? Which is good because then they can start loading all the CSS. And spoiler alert, they actually move the JavaScript up here as well for you, so they can start loading all the JavaScript. Which is good because then they can start loading all the CSS. And spoiler alert, or server-side rendering in the background as well, right? Which is good because then they can start loading all the CSS. And we can flush out to them all of this, right? Which is good because then they can start loading all the CSS. And spoiler alert, they actually move the JavaScript up here as well for you, so they can start loading all the JavaScript, which is great, right? So while they're parsing all this, they're loading all this stuff, and then we can be running all of our server-side rendering in the background. So multiple things are happening at once, so we're giving them the best experience that we possibly can. So that's why I'm splitting it. I'm just going to split it into parts. The first part, this part, and the second part, this part. So I can split it on what? Not rendered, right? So I'm going to just literally split it on that. HTML.split, not rendered. Now, typically, I would imagine most people would probably do something like, that's probably a more robust way of doing it, but I'm lazy and I'm not going to do that. I'm just going to do not rendered because it's already there. Okay, so that's parts. Now let's make a really basic. So while they're parsing all this, they're loading all this stuff, and then we can be running all of our server-side rendering in the background. So multiple things are happening. And spoiler alert, when a user makes a request, I'm going to give them the head first. So looking at my index.html again. When a user loads my page, immediately we can flush out to them.
Okay, that makes sense.
Do this part to go get the proper paths for all those different things. In other words, we can't just use the source file because it's not going to be client app.jsx at the end. It's going to be some hash named JavaScript. Okay? JSX.
So the idea here of doing this, okay, the idea here of doing this is because our project is going to build the HTML that we need for that file, and it will contain all of the SSS, all of the CSS, JavaScript, and because all of them has hashes attached to it, we need to resolve all of the paths of the resources. Okay? So this is something that is going to be generated before this file happens. So first we need to generate is, so first we need to tell React to generate like this. First you need to tell to our dev server of our mother bundler, hey, I want you to generate this output, the client side and then the server side, okay? I want you to generate is this, all right? And once you generate that, which will have, of course, a lot of those chunks of data with all the code splitting and that kind of thing, all of those optimizations, then I want you to read that and then split the document into two parts. It's split into two parts.
At the end, it's going to be some hash named JavaScript. Okay? I'm going to split it into two parts because when a user makes a request, I'm going to give them the head first. So looking at my index.html again. When a user loads my page.
Exactly. So when the user load my page,
immediately we can flush out to them all of this, right? Which is good because then they can start loading all the CSS. And spoiler alert, they actually move the JavaScript up here as well.
okay. When the user load my page, it will immediately, exactly, immediately load all of our head resources.
For you, so they can start loading all the JavaScript.
So they can start loading CSS in once the build is, once the HTML is generated, okay, so they can start loading CSS, and once the HTML is generated, they can so they can start loading CSS, and once the HTML is generated, they can or Vita, the model bundler, in our case Vite, put all of our JavaScript files at the head. Which is good because we can start loading all of them which is good. We can start loading all of them in the client, or once the client make a request. Once the client is making a request. Okay, and that's what we have is the HTML here that's split with not rendered.
Which is great that we possibly can. What? Not rendered, right? So I'm going to just literally split it on that. Express course. Parts. Now let's make a really basic Express app. If this is not familiar to you, it's totally fine. This is not an Express course.
Comes app, and here's where we're going to create this
app.use / assets express.static path.resolve. This is just serving all the static assets that we need to do. dir name ./dist /client /assets. This will serve all of our images, our CSS, our
Okay, now here we're saying is app.use the assets, whatever you define is on the assets after you build that. The assets, okay. And I want you to serve
JavaScript,
all of that.
all that stuff.
I want you to serve all of the content here, which is using express express.static exactly, and here where you say is the dir name with the dist slash, I think it's a dir name, the dir name, but you need to actually pass that as the result. Okay, path resolve whatever result you have there from the dir name and the this of the client, because after all that's what you want to load is the client assets. Okay,
did I import Express up there? I did, right? Oh yeah, sorry. That's app equals Express, or the other way around. Okay. And then here is the magic, what you've been waiting for. App.use.
Yeah.
We're basically saying on anything that's not served by a static asset, let React handle, okay?
Okay. Anything that is not handled or
.use. We're basically saying on anything that's not served by a static asset.
Okay. Anything that is not served by static assets,
let React handle.
Let React handle it. And you say app.use so that is any
request and response. So what did I say? The very first thing is we're just going to flush to them the header.
Okay. Request and response. Okay.
res.write parts 0. Immediately flush them all, everything that's in the head.
Okay. Anytime you are exactly anything that is not served by static asset, let React handle it, which is now flash the head, flash out,
Flush to them the header.
flush them.
Request and response. So what did I say? The very first thing is we're just going to flush to them the header.
Exactly. So the flush the heads, flush the head. Yes. So flush the head. So the first thing to do is this. The first things to do is to flush the head. To flush the head out.
Res dot write parts 0. Immediately flush them all, everything that's in the head.
Exactly. So flush the head. Immediately flush them on the head. Then the response. Now the request. On the request. On the request. Oh, on the response. On the response, you're going to say, right, immediately flash the first part of that. This is what a string. Immediately flash the first part of that.
Then const stream equals render app. Again, this is the app that we got here from dist server server app.js. We're going to give it rec.url and this object of on shell ready.
Okay, because here we're saying is const stream, and we're gonna say, hey, the render app is gonna take is the request.url, okay, and this second object here that we have to pass,
and this object of on shell ready.
Okay. Which is an object here. You say on shell ready.
Stream.pipe res. Okay. On shell error. Do error handling here. This would be
on shell
log it
ready.
out to your error service, log it out to your, I don't know, whatever logging service you're using. I'm not going to do anything here because we're probably already taking too long on this anyway. So anyway, that's what on shell error you would do there. And then on already, this is basically everything has happened, so we're done. So this is the last thing to write. Res.write parts 1. So this basically means everything has been written out. Because remember, React is going to give it to you incrementally. It's going to give you one piece, then another piece, then another piece, then another piece. On already is basically, all right, everything is done now, right? So we're good to go. We can write the tail of it, and then we can close the request.
Response.write in part 1.
With res.on So this basically, so we're done. So this is the last thing to write. Res.write parts 1. So this basically means everything has been written out. Because remember, React is going to give it to you incrementally. It's going to give you one piece, then another piece, then another piece, then another piece. On already is basically, all right, everything is done now, right? So we're good to go. We can write the tail of it, and then we can close the request with res.end. And then on error, like on an actual error, we can console log that out. Okay, so that's all of that. Lastly thing we'll say is console.log. Listening on http://localhost : port. I like to do this so then I can command click in my VS Code terminal and it'll take me directly there. And app.listen port. Okay, so stream.pipe, this is the important thing here. Stream, we're getting back from a render to pipeable stream, which is a node data type streams. When we pipe this together, we're basically saying the response object and the React stream are being connected to
the response object. Okay, the response object and
each
the
other,
response stream,
so that whatever is coming out of React is going straight to the user. Together, we're basically saying the response object and the React stream are being connected to each other so that whatever is coming out of React is going straight to the user. That is exactly what this does right there. If you have more questions about stream data types, I'm pretty sure Scott's course has got to talk about it, so watch Scott's .pipe React. The very first thing is we're just going to flush to them the header. Res.write. Again, this is the app that we name equals then 0. Immediately flush them all, everything that's in the head.
flush them.
Then const stream equals render.
Exactly, because there what you're doing is to, the first things to do is to flesh them out. Immediately flush them out. Force them to force something. Exactly, flesh them out and flush them. Put a flush in the ball. Flesh out and flush out. Immediately flush them out. Immediately flush them out to bring something into open line for examination. Immediately flush them out. Okay, immediately flush them out. The first thing to do is to immediately flush. Okay, flush them out. Flush them out. Pop up, bring up them. Flush them out. That makes a lot of sense. Okay, immediately flush them out. And then you're going to create the rent app here, where this is an object that you say on shell chain, which is something that comes from render app
stream
on shell
dot
ready.
pipe
On shell ready,
res.
what you're gonna do is to
Okay. On shell error.
Yeah, on shell ready, you're gonna get is the stream pipe, and the stream pipe, and the pipe is a function that comes from the functional programming. And this is a very, very interesting function because it will take the result from whatever function you are and then pass that to the input. In other words, once we're doing this, from the response we're saying is that now that we flesh them out, the first part of the header, because here we are constructing is this HTML that we're gonna send to the client. Okay, once we already build the assets properly with the code splitting and the server-side rendering for the client, in other words, we generate is the proper bundle, the optimized bundle that we're gonna send to the client. Okay, so once we did that, now we're gonna use is this particular function that comes from node stream, especially on React, that would allow us to render small chunks of data and send them as they are available to the client. So by doing this stream pipe function, what we're doing is connecting is the output from the connecting is the output from React to the response here. So whatever is the output that React generate, okay, I want you to now add that to the result, to the response here object. Then we also have on error on shell error. This is when you handle error here.
To your error service, log it out to.
Exactly. So on the shell error, this is when you do your server log errors, logging out to error service, whether it is GS or track GS. Okay, whether it's track GS, whether it's track GS.
Your, I don't know, whatever logging service you're using. I'm not going to do anything here because we're probably already taking too long on this anyway. So anyway, that's what on shell.
Exactly, whether it's on track.js, Sentry, track.js, Sentry, anyway. And the other is on shell, done.
Shell error you would do there, and then all on already.
Okay.
This is basically everything has happened, so we're done.
Already.
So this is the last thing to write.
Now this is when you say
res.write parts 1. So this basically means everything has been written out, because remember, React is going to give it to you incrementally. It's going to give you one piece, then another piece, then another piece, then another piece.
Exactly.
On already is basically, all right,
So because React is going to give us everything, exactly everything. Yeah, because React is going to give us everything. Because React is going to give us everything properly rendered, because React is going to give us every piece of render, and once that is done, we say, okay, now it is time to write the end of the HTML.
Everything is done now, right? So we're good to go. We can write the tail of it, and then we can close the request.
Now we can write the tail of it
with res.end. And then on error, like on an actual error, we can console log that out.
And here we can say is this. So console.log.
Okay, so that's all of that.
And on error here. And on error here is, let me just console log that up. I think we should receive an error. Yes, an error object here. And here we're going to show after that is the port.
Lastly thing we'll say is console.log listening on http://localhost : port. I like to do this so then I can command click in my VS Code terminal and it'll take me directly there.
Listening on, okay, listening on HTTP.
Listening, I like to do
on HTTP localhost port, okay. Listening on HTTP localhost port. Exactly. And we need now to listen to the port. We say app.listen, and any callback where we're going to listen.
Do this so then I can command click in my VS Code terminal and it'll take me directly there. And app.listen
on the port.
Okay, so stream.pipe, this is the important thing here. Stream, we're getting back from a render to pipeable stream, which is a node data type, streams. When we pipe this together, we're basically saying the response
where you got is this, render to pipeable stream, like so. This is something that comes from the render to pipeable stream, which is a stream data source.
One thing here, stream, we're getting back from a render to pipeable stream, which is a node data type, streams.
Which is a node data type. Okay, stream. All right. When it's connecting.
When we pipe this together, we're basically saying the response object and the React stream are being connected to.
Exactly. So the response object and the React output or the React pipe here are connected to
each other, which is a node data type streams. When we pipe this together, we're basically saying the response object and the React stream are being connected to each other so that.
So the response object and the React stream are connected each other.
Whatever is coming out of React is going straight to the user.
So whatever is coming from the React is whatever is coming from the React is sending to the user. It's going straight to the user. It's going straight to the user.
That is exactly what this does right there. If you have more questions about stream data types, I'm pretty sure Scott's course has got to talk about it. So watch Scott's course on Node.js, because to Google, it looks like you're slow, because it's worried about, as a crawler, getting everything all at once. So what you might do here is, like, if it is the crawler, do nothing here, and then on already, which basically means everything is already, you'd say something like, if it is the crawler, then you would do this here. Because once you have the whole thing here on already, this would just dump everything all at once, because everything would be ready, right? So it'll maintain that back pressure, and then you can just dump it out all at once.
This is exactly. If this request comes from
because everything would be ready. The crawler here, and then on already, which Google, it looks like you're slow. Consider doing stream data types. I'm pretty sure Scott's course has got to talk about it. So watch Scott's course on Node.js.
Oh my God.
There is one thing that you might consider doing if SEO is really important to you, which I imagine to many of you it is. Rendering things to stream can be a problem because to Google, it looks like you're slow.
Exactly. And now it comes with another problem. Okay. Holy moly, bro. Let's go back here to this. This is the final document. So our server GS will look like this. So server GS will look like this. All right. If SEO is important to you, which is something that it is for a lot of people, rendering things using stream is streamed to Google is slow.
Because it's worried about, as a crawler, getting everything all at once.
Because as a crawler is worried about to get everything at once. Oh my God. Okay.
It is rendering things to stream can be a problem because to Google it looks like you're slow, because it's worried about, as a crawler, getting everything all at once. So what you might do here is, like, if it is the crawler, do nothing
Exactly.
here, and then on already, which basically means everything is already. You'd say something like, if it is the crawler, then you would do this here. Because once you have the whole thing here on already,
If this
would
is
just dump
the
everything all at once, because
crawler,
everything would be ready, right? So it'll maintain that back pressure, and then you can just dump it out all at once.
if this is the crawler,
General gist of how you would handle
do
that.
something here.
Okay, so let's all at once.
If it is the crawler, do nothing here. For SEO, exactly. And if it is, and on already, exactly. If this is the crawler, we can sort of maintain the back pressure, and then you can dump it all at once. Yeah, it'll maintain the back pressure. Yeah, it'll maintain the back pressure. Yeah, it'll maintain the back pressure. Yeah, it'll maintain the back pressure, and then you can just dump it all at once. And then you can dump it all at once. And then you can dump it. Then you can dump it all at once. And that is here. By saying is this: stream pipe like so. Say stream dot pipe dot res. Exactly. Holy moly. Holy fudge.
General gist of how you would handle that. Okay, so let's make sure I'm not out of my mind. It's always a possibility. npm run, you want to run build client.
Client first.
You can see here I got a bunch of stuff.
Okay. So now let's go. That I'm not out of my mind. Yeah, so now let's go that I am not out of my mind. Okay. Run npm, which is build the client side, the client, by running the npm, this command. By running is the client side, which is the npm build, this one. Okay. npm, this one. npm, oh come on, npm run build client. Okay. Okay. There you go. Is this. And we can also build a server.
Output there. I'm going to do npm run build server. Got a bunch of stuff coming out here for the server.
Exactly. So what we're gonna build is the npm run client, and then npm run server is gonna do this here. Alright. Let me open up the terminal here. Thank you for doing that. There you got it. npm run build client. You say, hey, who the F are you? Glad you asked. Is the server side rendering. It say, hey, I couldn't find that because that doesn't exist. npm install. I want to use this PNP for that because I don't want to install all dependencies per project, and there's a lot of projects here. So no. That's right. It's available, as well as all of this, which is great. We use PNP here. Alright. And now it is time for us to say npm run. We can say this. npm run build a client. So it will generate all of these assets for us. Screenshot here. Let me take a screenshot for this. Where we are actually generating is this. Can you please? Exactly. Like so. Oh, and I love it because now this actually doesn't show my data exactly, which is good. So I'm recording this. Now I want to take a snapshot here. And the other is the server. That was quite fast. Screenshot here. That was the server. Use query and the index for that. As you can see, it's actually squeeze that out because you're using use query. So if now we take a look at that, what we generate. So in your case is take a look at this and say, hey, you know what? Is this one? Where is our files generated? Pictures, no, it's on download. They last open. They modify it. They created. They modify it. It's interesting. It's not in downloads. Perhaps it's on desktop here. Exactly. So the first one is the client. Exactly. As you can see, it actually generates all the assets here under the asset. I want you to resolve all of the assets here and send that for us. And anything that is not assets, I want to let the React handle that. Holy moly. I want to React handle that. Yeah, I want to React handle that. No, is here. Oh, wait. Okay. Okay. I want you to React handle that. Alright. Okay, I want you to React handle that. And not only that, yeah, not only that, but yeah, let me close this as well. But then now it is time for us to run the server.
Assets, cool. And now I can say npm run start. And I have a server running.
So here we're gonna say is go back to the code here. Here we say is what? Okay, and here now we run is this npm run start. I don't need to put this experimental feature here. I think they do that, by the way. No such file or directory. Okay. This client, perhaps this client index HTML. Nope, leave like that. You got this. You generate all of the assets, the index. For some reason, where do we have our server? That's a good question. Where is the server located, bro? What is the server file? Is this? Okay. So server is where it's supposed to be. I think so.
On 3001.
Perhaps. Yeah, we are in the proper that, which is this client and assets. Client and assets in plural. That's right. And it failed here. Is this client index.html. You say not such file or directory. Open here. Okay. Yeah, we are reading that path resolve with the their name of that. Okay. It's because I think it's because he's looking at the root folder. That's what happened. And he was telling us that I want you to take a look is at the current directory where you are, and then that. Yep. So now we're listing at the proper port. When you navigate to this, it'll show off that. It of course crash. This goes to say, hey, this is experimental feature. What the is this one? Yeah, let me close this. Render to pipeable string is not defined. Might be on the server app. That is mapped to this. Where here we're saying is this render app. On the server app. Let me continue to look at that.
Might have an error. No. There we go. I don't know what's going on there.
Okay, it actually loaded that probably. Okay, here we go with this no versions. It said render to pipeable stream is not defined. Okay. Render to pipeable stream. Didn't put that properly, I think. Yeah, I misspelled that. Human error as usual. Alright. Let me now build the client again. Okay. Exactly. And the server again, it will override that. Okay, I don't think that was override. If I navigate to this, that's right. Yeah, it thinks that it's not inside project root and will not be empty. So yeah, it won't work properly. So it means that I need to clean that out. Is this file for that? Yeah, please be my guess. Let me now run the client again and run the build the server again, and now say pnp run star. Let me navigate to this. All right, and so you can follow me along here. Yeah, I don't think.
Can't import from FS. Import. So we have a that goes here. Put so that.
Oh,
now what's cool about
I never use the ops here. That's one of the reasons why it never showed that, which is the ops. Exactly. Okay. Of course, it will never load anything. Okay. Go back to the code here. We're missing some property here. Now let me do this again. Okay, and that is again, build the client, build the server, and then run the server. Navigate to the server. Okay, and we can see we got is this. Okay, where actually no road matches location access in the switch, which is the favicon. Okay,
All right, first thing. Server running on 3 start, and I have a server running on 3001.
and for some reasons we are not loading. Oh my god, really? And for some reason it's not loading that resource. It's a no route match for location for this. Okay, if I reload this, it is properly loading the data, but without is the assets. Might be an error here. Is no route matching location asset index here? No, it's not this. Ghost repo, ghost website, project folder. Okay, project folder, course website here. Exactly on the server we got is this. Not render completely. It's like not loading the proper assets. Yeah, it's like not loading the proper asset because exactly it's like not loading the proper assets. Okay. It's like not loading the proper assets, which is here not rendered. Not loading the proper assets. Okay, what the fuck is? So we might not provide is the. I think we okay. Okay. Yeah, okay, that was happening. Okay, okay. Yeah, it's more like it's not able to load the assets here. Now if we run this and then we navigate to there, you're supposed to load those assets properly, but it tells this location is not. Oh, because it's here, my friend. Exactly. Because it's here. You have to tell, hey, this is where you need to solve those assets on here, and now it's loading properly as it is. Okay, which is good. Uh, Again, human errors as usual. It's actually taking quite a lot here. Okay, here we go. Okay, that's interesting. So as you can see here, is actually loading all of our research as expected.
You can see here I got 1001. So one of my favorite things to do here is to look at the page source, because that'll tell you what it's getting on first load.
Exactly. So now let me take a look at what it's getting at the first load. View page source. And as you can see, we are getting is right after the root, all of our HTML here hydrated. It's a long tail here. All of our HTML here hydrated.
You can see now it's getting a bunch of this stuff on.
Okay. Exactly. Why do you think is that, bro? It's like, oh my god. Anyway. So after running the server, we inspect our page to look at what React is sending as our initial page. Okay, as you can see, the HTML here is massive. I can paste that, but it's like is all of this. This is the relevant part here. The relevant part is whatever is doing behind the scenes here. It's adopt me and all of this. And then in the body he's pasting that. So the relevant part is what is after the root file. After the root component, or after the root HTML tag. After the div HTML, after the div tag, after the root ID HTML, after the root After the root ID div tag. Yep.
First page load, like all of the various different animals and the select and everything like that. But notice on the first load, we're getting no pets found, right? That makes sense. It's not doing any AJAX on our server, right? It's just going to render out the very first thing. So if I refresh here, notice that we get no pets found immediately. There's no loading once it's there, right? We're getting immediately loaded out the first set of HTML. So this is what I was talking about. You're going to get that first state loaded immediately for that user, and then it's going to start making all the AJAX calls.
Mm-hmm. So you are going to get the first HTML to the user, and then do all of those AJAX call. This is essentially what it's doing this.
Right. Then it's going to start loading all that kind of stuff. Does it make sense? It's a lot of like machinery to plug together, but
yeah, there is a lot of machinery plugs in together. Yeah, there's a lot of machinery to plug in together. Yeah, my friend. There's a lot of machinery to plug in together.
right. Then it's going to start loading all that kind of stuff.
But it's really cool.
Does it make sense? It's a lot of like machinery to plug together, but it's pretty cool, I think. It's really always really hard to tell because we're doing it like all local development, right? And so there's no round trip. Our round trip is just electrons in our laptop.
Yeah, there is a lot of machinery to plug in together. But it's really cool, I think. Yeah, I think too. So if you are in your so if you are working in your local computer, it is just atoms. It is just atoms in our laptops. But for network applications, but for web app, but for distributed web apps,
right? But this can make a big difference when if someone's coming from like India to US East, right? That can
okay. But for distributed web apps, like from India to US, or Argentina to Australia, that can make a difference totally if you stream that as it is.
make a big difference.
Is there a way that you can simulate that?
Yeah, I mean,
Your server's in a Docker container or something?
certainly you can do that. You can certainly slow it down that way. The easiest way always is if I go to like the network here, you can always choose throttling here, and you can put yourself on like, oh, I'm on Firefox again. But you can put yourself on like good 3 or regular 3G, right? And I refresh. Now Firefox is going to make it seem like everything's going a lot slower. So I use that quite a bit. And if you don't use it on you should look at your app on various different speeds. You should also look at your analytics to see what devices and what speeds people are accessing your computer on. So then you really know who to target.
Interesting.
Who wants to do something silly and dumb with server-side rendering? Okay. Do not do this today. This is kind of a preview of what's coming, but it was so easy to do.
Exactly. Brian configured the project to run the fetch request on the server so the results are rendered server side and sent to the user with the rest of the server's rendered markup.
That I think is pretty compelling. What if you want to show everyone?
Okay. That'll be all for this video. Take care. Bye-bye.